Hello friends, we are going to solve numerical number 1 based on RL circuit. Coming to this numerical, in this circuit, this is switch number 1, S1 and S2 both are closed at t is equal to 0. Then find out the current equation for inductor. For that, we have to calculate the value of IL0, IL infinity and tau, and we have to put all this into the equation. ILT is equal to IL infinity minus IL0 e to the power minus t upon tau. So first I will calculate IL0, then IL infinity, then time constant tau. So starting from infinity, minus infinity, at t is equal to minus infinity, we will find out at t is equal to minus infinite if there is any input or not. So this will be 6 ohm, this switch is open, and this is 3 ohm, and this switch open too. If you will see, then both the switches are open and there is 0 voltage applying across the inductor. So the VL minus infinity is equal to 0. It means the inductor will be uncharged at infinity. It means if we will forward from minus infinity to 0 minus, inductor will remain unchanged. It will remain uncharged. So IL of 0 minus will be equal to 0. At t equal to 0, by observing this circuit also we can see that the value of IL0 minus is equal to 0 because the input on that inductor was 0. It means minus infinity to 0 minus, it was remained uncharged. Now at t equal to 0, we will see at t equal to 0 both the switches will be closed, and we can write here 6 ohm. Initially it will be what? Uncharged, and the current is 0, and this is your 3 ohm and this 18 volt. Now we can calculate the value of VL0. VL0 will be coming out to be 6 upon 6 plus 3 into 18 volt by the voltage division formula, and that will be coming to 18 volt. So the VL0 is equal to 18 volt, but we do not need this value. Why? Because we have calculated this value to cross check, whether from t equal to 0 to t equal to infinity the inductor is charging or not. Here it is not equal to 0. It means the inductor will start charging from t equal to 0 to t equal to infinity. T is equal to 0, we calculated IL0 minus is equal to IL0 is equal to IL0 plus is equal to 0. So IL0 is equal to 0, and now we will calculate the value of IL infinity. At t is equal to infinity, this inductor will be fully charged, and that can be represented as short circuit. So this is your IL infinity, and this is 6 ohm, this is your 3 ohm, and this is your 18 volt, and this is your 6 ohm. So from here we can calculate the value of IL infinity. This 6 ohm will be 3 ohm, 3 plus 3 6, this will be 3 ampere, and this will be 1.5 ampere. So IL infinity is equal to 1.5 ampere. and for tau we need to calculate the value of R equivalent. We will look across this inductor after t greater than 0. So this will be your 6 ohm, this will be 6 ohm, and here we will look for R equivalent and it will be 3 ohm here, and the 18 ohm will be short circuited. The R equivalent will be equal to 6 plus 6 in parallel with 3. So that is coming out to be 6 plus 2, that is 8 ohm. The R equivalent value is equal to 8 ohm. Now we have all the values. IL0 is equal to 0 ampere. IL infinity is 1.5 ampere, and tau will be equal to L upon R equivalent. It means the value of L is 1 Henry upon R equivalent is 8 ohm. So the tau value will be equal to 1 upon 8. Putting all this value in shortcut formula, and shortcut formula is what? ILT is equal to IL infinity means 1.5 minus 1.5 minus 0 e to the power minus t upon tau, and tau is 1 by 8 means 1 by 8t. So the value is 1.5 1 minus e to the power minus 8t. The current equation for inductor is 1.5 1 minus e to the power minus 8t, and by derivating this we can calculate the value of VL. So now we are going to find out the value of VLT. We have the value of ILT is equal to 1.5 1 minus e to the power minus 8t. We have the value of ILT is equal to 1.5 1 minus e to the power minus 8t. Now we can calculate the value of VLT is equal to L DIL by dt. We note the value of L is equal to 1 Henry and DIL by dt. 1.5 0 minus 8 into e to the power minus 8t, and that is our coming out to be 1.5 into 8 e to the power minus 8t, that is 12 e to the power minus 8t. This is the equation of your voltage across inductor. Thank you.